Here are the notes for day 62. This is section 7.3, which is using the shell method. So there's a second method for finding the volumes by rotation, and it's a little bit different than the disk and washer method, and actually there are times when the disk and washer method doesn't work. So if I take this function here, y equals x minus 1 times x minus 3 squared, and if I plot it, I get this. Trying to use the washer method, we're going to run into a problem. If I take the outer point, rotate it around in the shape of a circle, and then add a little bit of thickness, I can get the volume of that disk. And then if I take the inner point, rotate it around, add a little bit of a thickness in the y direction, and find a volume, I would get the hole that gets cut out to turn this into a washer. But the problem is when I go to find the radius, this radius and this radius are using the same function. So when I go to subtract r squared minus r squared to find the volume by the disk method, I'll be subtracting the function and I'll wind up with 0. So the way to remediate that or to fix that is to use what's called the shell method. So if we look at this function here, and when I take a point on that function and rotate it about the y-axis, I'll get a circle like this, and instead of finding the volume by calculating this area and summing lots of circular areas, I'm going to take that circle, drop down a perpendicular, and then find the area of a right circular cylinder, and then sum the areas of lots of those right circular cylinders as the point moves along the curve. So one way to see this is to take a sheet of paper, turn it into a right circular cylinder, like this, which doesn't really have a volume, but then take that width of that paper and turn it into a volume by doing lots of right circular cylinders. So this thickness here is what's going to create the volume. So this time the thickness is going to be coming from the height of the right circular cylinder. So we still rotate our point in the shape of a circle around the axis of rotation, but then I drop down a perpendicular, and this thickness is going to create the volume that we calculate. So imagine you had another right circular cylinder with another area here. So the first area plus another area plus another area would sum up to be a volume. So the formula for the area of a right circular cylinder for the surface area, or the label of a soup can, is 2 pi RH, 2 pi radius times height. So again, we have to find the thickness, and in this case, because the height is going to turn into a thickness, I have a delta x, which is why this is a dx. The radius is the x coordinate here, which is why there's an x, and then the height is the y coordinate, which is here. The y coordinate is the height. So, and if it's going to be a dx, then this x part is fine, but this y needs to turn into some sort of an x statement by solving the function for y and substituting in there. And you'll see an example of that in a second. So to rotate around the other direction, around the x-axis, same thing, find a point on your function, rotate it around in the shape of a circle. This time the thickness is going to come from the height of the right circular cylinder. So since that thickness is in the y direction, it's a dy. 2 pi RH, the radius, is going to be the y coordinate, and then the height is going to be the x coordinate, the point that you used there. And again, since I want dy, this x term needs to be turned into something in terms of y. It's a little bit easier to see with examples. So let's go back to the one that didn't work using the washer method. We'll use the shell method instead. So the function I have plotted here, I'm going to take a point on that function, rotate it around in the shape of a circle, drop down a perpendicular, and say that when I go to find my surface area, or the label of the soup can, I'm going to later on make that thicker so that that single sheet of paper turns into a whole bunch of sheets of paper, which turns into a volume. So I know I'm going to do everything. The thickness comes from this direction, so that's a dx. So 2 pi RH dx, that's the key. What's the radius? The radius is just the x coordinate. What's the height? The height is the y coordinate. The second one needs to be changed. This needs to be changed because everything is in terms of dx. So my y gets replaced with this statement here. And then we're done. 2 pi, antiderivative from 1 to 3, because my function exists from 1 to 3 in the x direction. 1 to 3 in the x direction. Antiderivative of that using a calculator, you get that statement there. So the key to this is just going to be drawing reasonably accurate diagrams so that you can figure out what's your height and what's your radius. So next example, find the volume by rotating the area formed by these two functions, and x equals 0 about the line y equals -1. So a parabola we can draw pretty easily. Let's right there. So the parabola is going to be the blue part. X to the 2/3, since the exponent is less than 1, it's going to be traveling kind of like a root function, since the exponent is less than 1. That's x to the 2/3. And then at x equals 0, start here, and the two functions cross at x equals 1. So if I'm going to do a dx, it's going to go from 0 to 1. If I'm going to go do a dy, it's also going to go from 0 to 1. Since I'm rotating around the line y equals -1, right here, and I'm going to take and draw my circle. So I'm going to pick a point on the first function, y equals x to the 2/3, and then when I rotate that around, I need a right circular cylinder. When you have two functions, now the right circular cylinder, the height is going to go between the two functions. So once I pick my point, and it doesn't matter which curve you pick your point on, just pick a point, rotate it around the axis of rotation, draw your height, but then stay between the two functions that you're working on. So since the height of the right circular cylinder has a width going this way, that's a dy, and now the height is going to be the difference between those two x coordinates. So setting up 2 pi rh, 2 pi radius is going to be the y value plus 1. Okay, if I'm rotating around the line y equals -1, this coordinate here to the axis is going to be the y coordinate plus 1 for both of them, y coordinate plus 1. And then the height of the right circular cylinder is the difference between these two x values. So x blue minus x red. X blue minus x red. The blue is the parabola, so y equals x squared. The red is the 2/3 function, but I need them in terms of y, so I had to solve both of those for x. Okay, the blue x is right here, but solve for y, it's y to the 1/2. The red x is here, but solve for x, it's y to the 3/2. And I have everything ready to go. 2 pi radius height. Again, plugging that into your calculator, you get 2.394. Last one, we're going to find the volume of a donut. Okay. Set up the integral and use your calculator to find the volume of the solid generated if x squared plus y squared equals 1 is revolved around the line y equals 3 using the shell method. Hopefully you know that x squared plus y squared equals 1 is a circle with center at the origin and radius 1. We're going to revolve it around the line y equals 3. Okay. And what I'm going to do is I'm going to use a little bit of symmetry and only find the volume of this right half of the circle and then just double it by symmetry. When I get the volume by rotating this half circle around, that's going to be the same as this half circle, so I can just double it. So I'm going to take a point on the function, rotate it around the axis of rotation. Okay, now I need my right circular cylinder, so I'm going to go perpendicular backwards, back to the y-axis. There's my height of my right circular cylinder. Since that thickness is going to be in the y direction, I'm going to be using a dy. Remember, we want the height not to be just a straight single sheet of paper, but a bunch of papers, so that thickness comes in the y direction. So I set up my dy, and my 2 pi rh, the radius, is this length here. So to get that radius, I need to go all the way up to 3, but then subtract off the y coordinate. So the radius is going to be 3 minus y, which I wrote down right there. That's the radius. And then the height is going to be this x coordinate of the function. What is the x coordinate of the function? Well, x is this. If I take this circle function and solve for x, it would be plus or minus root y squared minus 1. But since I'm only using the right half of the circle, I'm only going to use the positive part of the square root. So now I've got my height is positive root y squared minus 1. So again, I've got 2 pi rh set up. My y values, because it's dy, are going from -1 to +1. In other words, this point is traveling from -1 to +1 and creating all those right circular cylinders. And now I'm going to double it so that I get the volume of the whole donut, not just half the donut. You don't want half a donut. That's no good. So then figuring all that out, setting up and using your calculator, you get 59.218 is the volume. Okay, so there's one more example to go, but I think I'm going to leave that for the day 63 video. That's it for the shell method.